Alright, your test is coming up pretty soon, so you gotta learn how to do all of these and do them as comfortably as possible and as quickly as possible so you can finish the test in one class period. And that's gonna be our goal, just to kind of talk you through how to do this as quickly as possible and have all the knowledge that you need. Okay, so we're gonna have conversions just like we did at the beginning of the 9 weeks. These are easier. These are kind of like what got it started with stoichiometry. So it says calculate the mass of 2.35 times 10 to the 27 atoms of carbon. Okay, so start with your given. 2.35 times 10 to the 27 atoms of carbon. Okay, so it looks like that. Alright, so anytime you use atoms, you're going to use Avogadro's number. And so since this is atoms, this is also got to be atoms of carbon. And atoms goes attached to the number that we just mentioned, Avogadro's number. 6.02 times 10 to the 23rd. Right on top, that number is always equal to 1 mole of carbon. Okay, if I were to cancel these two guys, that means that I'm left with moles of carbon. But that's not what the answer or the question is asking us. And that's not what our answer needs to be. It needs to be to calculate the mass. So we're going to draw another little box. And this is where we're going to do mass in moles. So if this is moles of carbon, this has got to be in 1 mole of carbon. How many grams of carbon do I have? Look it up on the periodic table. It's 12.01. Okay. So pretty much you calculate across. 2.35 times 10 to the 27th times 1 times 12.01. And then you're going to get an answer. In this case, 2.82 times 10 to the 28th divided by, well, this multiplied by 1 is still Avogadro's number. 6.02 times 10 to the 23rd. Alright, you divide the top number by the bottom number. Sorry, right over here. And your answer comes out to 46,882.89 grams of carbon. Okay. Next question, how many molecules are in 44 grams of H2O? Okay, start with 44 grams of H2O. Okay, that's grams of H2O, so this has got to be grams of H2O. Anything with grams is always per 1 mole of the same thing. Grams of H2O, the molar mass of water is 18.02, just like that. So molar mass. 18.02. If I did the cancellation, okay, moles of H2O is not what I want. I want molecules. So one more step. So if that's moles of H2O, this has got to be moles of H2O. Actually, one. This is going to have to be molecules of H2O. So in that case, remember that any of those words, molecules, atoms, representative particles, formula units, that's all attached to that number that we call Avogadro's number. 6.02 times 10 to the 23rd. And molecules we're going to abbreviate as molec. And that cancels there. So now you multiply across. Multiply that across. Top number divided by the bottom number. You get a final answer of 1.47 times 10 to the 24th molecules or molecs of H2O. Just like that. Okay. So it's going to review what we did, but which you'll be expected to know for this exam coming up. Okay, so we move along. Okay, now we do the stoichiometry problems. We've been doing those recently, so you guys should be experts at that. So first of all, determining what type of problem this is. Always start with your given. Your given is for 5.66 moles of O2. So they want me to find, they would give me moles and they want me to find grams. So it's a mole to mass problem. So mole to mass problem. That much I know. And in a mole to mass problem, I also know that it's got 6 boxes. Just like that. Start with your given. 5.66 moles of O2. Okay, that means that if this is moles, top and bottom, it's got to be moles. This has got to match, so it's moles of O2. This has got to be a different compound, specifically the one we're looking for, CO2. The numbers that go with moles and moles are the coefficient. CO2 is 4, so we put a 4. O2 is a 5, so that's where we get the 5. So that cancels. Okay, so we bring this over, moles of CO2. If we did a step that has moles and moles, the next one has to have grams and moles. We already got our moles, so we need our grams. CO2, and it's always per 1 mole. Our molar mass for CO2, 44.01. Okay, so you multiply the top numbers, multiply the bottom numbers, the top divided by the bottom, the final answer. Make sure you have the right unit. I won't calculate this one for you because I think I've done pretty much most of it. So it's going to be some number grams of CO2. And if all else fails and you can't remember what unit to use, I mean, just go off from the question, which is asking how many grams of CO2. And should be your answer, grams of CO2. All right, question 4. Let's try and figure out what type of question this is. All right, our given is grams, so it's a mass to what we want to find, how many moles. So mass to mole problem. And like the other one, it's got 6 little boxes. Okay, so 50 grams of H2O. All right, so that's grams of H2O. That's got to be grams of H2O. Anything that has grams has to be per 1 mole of the same substance, H2O. Grams is giving you a hint. Your molar mass should go here. So molar mass for H2O, 18.02 grams per mole. Okay, that cancels there. When I've done moles and grams, that automatically tells me that this should be moles and moles. It's got to be moles of H2O, so it matches diagonally. And anytime you have a moles and moles step, that's going to be of the other compound mentioned. So in this case, acetylene, C2H2. In front of these moles are the coefficients. So for acetylene, it's a 2. That's why I'm going to put a 2 here. And for water, it's also a 2, which is why I'm going to put a 2 there. Okay, so now that I've got this one down, now all I have to do is multiply my 50 by 1 by 2, get some number. 18.02 times 2, get some number. Divide the top by the bottom. And that's my final answer. So I'm going to have some answer. And since that's remaining, moles of acetylene, C2H2. Just like that, which is going to answer my question. Okay. So now we're at number 5. So how many moles of O2 are needed to react with 9.20 moles of C2H2. All right, so our given is moles. So this is a mole to what we want to find, mole. So mole to mole problem. That's the easiest of all the stoichiometric problems, which is good. It's faster. So you start with your given. 9.20 moles of C2H2. And then if this is a moles given, that means these guys are going to be moles. Anytime you start with moles, then you have moles on top, moles on the bottom. This has got to match that, so it's C2H2. And the top one's got to be the other one they're looking for. So in this case, oxygen. We don't have to find molar masses on a mole-to-mole problem. All you have to do is look at coefficients. So O2 is 5, and C2H2 is 2. Okay, so all you have to do for this one is multiply 9.20 times 5, divided by 2, and whatever your answer is, make sure you put moles of O2. Just like that. All right, we're now at number 6. Okay, number 6, they're giving us mass, and they're wanting us to find mass again. So this is a mass-to-mass problem. That right there tells me 8 boxes, 4 on the top, 4 on the bottom. 23.55 grams of O2, that's our given. If this is grams of O2, this has got to be grams of O2. And anything with grams, again, 1 mole of the same substance. Grams, that's the molar mass of that substance. So oxygen, 2 times 16, so that's 32. Just like that. That cancels there. Now that I've used grams and moles, my next step, have moles over moles. These right here are going to be my coefficients. This has got to be of O2, so it could be the same. And this has got to be of the other compound we're looking for, H2O. So moles of O2 cancels moles of O2. Again, we need our coefficients. H2O, it's a 2. So we put a 2 here. O2, it's a 5. So we put a 5 here. Okay, now that I've used moles and moles, that means moles and grams comes next. So this has got to match diagonally. So this has got to be moles of H2O. This has got to be grams of H2O. Always with grams and moles, you're always using that 1. Never changes. Okay, and the molar mass of H2O, 18.02. Okay, so multiply the numbers across, the 23.55 times a 1 times a 2 times 18.02. Get some number on the top. Then multiply 32 times 5 times 1. Get some number on the bottom. Divide the top by the bottom. And you're going to get some answer that's going to read something grams of H2O. And that's going to answer the how many grams of H2O. And of course, your cancellation leads to only having grams of H2O. And now for the most recent stuff, which is our limiting reagents. Okay, this one, remember you're looking at 2 mass-to-mass problems. One of them for the first number given and the other one for the second number given. Okay, so I'm going to set those up. 12.30 grams C2H2. Gotta have my 8 little boxes. Okay, gotta do the same for 10.47. 10.47 grams of O2. 8 little boxes. Okay, so this is grams of C2H2. So this has got to be grams of C2H2 per 1 mole of C2H2. Molar mass of acetylene, 26.04. right there. Okay, that means these guys cancel right here. If I have moles and grams, that means this will be moles, this will be moles. That's C2H2 because it's got to match this one. This has got to be the other one mentioned. So in this case, O2. We got to use the coefficients that we used. So let's see, this one's O2, so therefore O2 has a 5 in front of it. So that's 5. And C2H2 has a 2 in front of it, so that's 2. That cancels this. So we have moles and moles. Next step has to be moles and grams. So it's got to match. Remember, moles and grams is always per 1 mole of the substance diagonal here. And this is going to be grams of the same substance, O2. Anytime you have grams, you're getting the molar mass of that compound. So it's oxygen. 2 times 16 is 32, so the molar mass is 32. Okay, so 12.30 times 1 times 5 times 32, whatever answer. 26.04 times 2 times 1, whatever answer. Top divided by the bottom. Okay, in this situation, I'm going to have to give you what the answer is so that we can find the limit. So in this case, it's going to be 37.79 grams of oxygen. Just FYI, this is telling us how much oxygen we need. Okay, so now we are going to do the next one. So the next one, 10.47 grams of O2. That means that's got to be grams of O2. This has got to be 1 mole of O2. Grams, molar mass of O2. We said that's 32. That cancels with that. That's a mole and gram step, so therefore this will be moles and moles step. This goes diagonally. This is O2. This is of the other compound we're talking about. In this case, the acetylene, C2H2. We use the coefficients. For O2, we said the coefficient was 5. So there's a 5. For acetylene, the coefficient is 2. Just like that. Okay, that cancels there. We bring this down. This will be 1 mole of the same substance, C2H2. And then this has got to be grams of acetylene. So the molar mass for acetylene, 26.04. Okay, multiply across on the bottom, divide top by the bottom. Your answer is going to be 3.40 grams of acetylene. Again, representing how much we need. Okay, so let's find our limit. Our limit is going to be the one that we don't have enough of, that we can't meet the amount that they're asking us to have. Okay, so we need 37.79 grams of oxygen. But this is how much we have. Right there. So, if you notice, what we have is not enough. That's how much we need. So, what we have is way less than what we need. So, therefore, O2 is your limit. That's what's going to make it all stop. Okay? If you want to make sure, look at the rest. 3.40 grams of acetylene, that's how much you need. But yet you have 12.30 grams of acetylene. So as you can see, we have more than enough from what we need. So that's called your excess. So acetylene is your excess. But the question is, which is the limit? So this is your limiting reactant. So oxygen would be your limit once again. And just because you know that now, that means that you're going to use that information for the rest. Okay, so the question asks, how many moles of carbon dioxide are produced? Since we know that oxygen is our limit, that's the number we're going to use. If this would have been our limit, that's the number we would have used. But that's not it. It would be this one. So 10.47 grams of O2 is where we always start. Okay, it's asking us for how many moles of CO2 are produced. So this is a given of mass to find out mole, so it's a mass to mole problem. So this grams of O2 means that this will be grams of O2 and this will be 1 mole of O2. Grams, the molar mass of O2 is 32. 16 times 2 is 32. That cancels there. That gives us moles of O2, but that's not what we need. What we need moles of CO2. So now it's a mole over mole problem, or step, sorry. So that's got to be diagonally the same. So that's moles of O2, and this has got to be moles of CO2. We use the coefficients. So the coefficient for CO2 is 4, and the coefficient for O2 is 5. So now we multiply across, top number divided by the bottom number, and you're going to get some number moles of CO2. Okay. Last question is asking how many grams of the excess is left over. For this one, actually, we need this information. Okay. Our excess here was acetylene. Remember that I told you we had 12.30 and this is how much we need? Okay. To figure out how many grams of excess are left over, you just subtract this one by this one. What we have by what we need. So it's going to be 12.30 grams of C2H2 minus 3.40 grams of C2H2. And I'm sure you guys can calculate that. It's just a subtraction problem. Okay, so we're done with that one. Last but certainly not least. Okay, what is the percent yield of H2O? If 6.98 grams are produced from 10.45 grams of C2H2. What I said before is that you're given, this is a mass to mass problem, and then you go into percentage. So I could tell you, you could start, by drawing your 8 little boxes. Just like that. And the question is, what goes here? Is it this number or this number? Which one do you pick? Okay, you're going to pick the one that's in your reactants. This is your reactants, this is your products. So H2O, it's over here. It's in your products. You don't want to pick that one. Okay? C2H2, it's right here on your reactants. You want to pick that one. So therefore, that's your given. 10.45 grams of C2H2. Okay, so that means that this is going to be grams of C2H2. This is going to be 1 mole of C2H2. We need the molar mass of C2H2, and that was 26.04 from all the other ones we've done. That cancels, that cancels. Okay. Next step, moles over moles. All right. So that's going to be of C2H2. And this one's going to be of the other one mentioned. So in this case, H2O. Using the coefficients, H2O is 2. C2H2 is 2. 1 mole of H2O. Grams of H2O. And again, it's like any other molar mass problem I just went over like a lot of times. Okay. Cancel all the things that need to be canceled. So multiply 10.45 times 1 times 2 times 18.02, some number. 26.04 times 2 times 1, some number. Top divided by the bottom. Okay, and in this case, I'm going to share the fact that the answer would be 7.23 grams of H2O. And this represents, in this case, my theoretical. Theoretically, this is how much should have been produced. But what the question is telling me is that you actually produced 6.98. So we find our percent yield. And percent yield, if you recall, is our actual over our theoretical times 100. So our actual amount is in the question. It was the other number that was given to us, so 6.98 divided by our theoretical 7.23. That answer times 100, okay, gives you a grand total of 96.54% H2O. Okay, with all the talking and everything that I explained, that's at 26 minutes. Remember, we have a 45-minute class period, so if you play all your cards right, you remember, you study, you should be able to finish this test by the end of the period without a problem. But again, all up to you. Everything you need is here. I explained it step by step. You have the other tutorials. If you need any help, you know where to ask, okay? And that's the end of the video.